Για την καταπολέμηση της κλιματικής αλλαγής, στόχος είναι περισσότερες ΑΠΕ, περισσότερες ανανεώσιμες πηγές ενέργειας, και τα αιωλικά πάρκα έχουν ένα μεγάλο μερίδιο σε αυτό. Η Θράκη έχει πολύ αέρα. Έχει χαρακτηριστεί μάλιστα σαν περιοχή αιωλικής προτεραιότητας για την εγκατάσταση αιωλικών πάρκων.
Τα τελευταία 15 με 20 χρόνια έχουν εγκατασταθεί πάρα πολλές ανεμογεννήτριες στον Εύρο και γενικότερα στη Θράκη, με αποτέλεσμα σιγά σιγά να αρχίζει να υφίσταται μια πίεση τόσο στο περιβάλλον όσο και ακόμα και στο ανθρωπογενές περιβάλλον, γιατί αρχίζουν και καθίστανται πλέον και γύρω από τους οικισμούς.
Σε αυτή τη μικρή περιοχή του Εύρου και της Ροδόπης, επιπλέον των 276 ανεμογεννητριών που έχουν ήδη κατασταθεί και λειτουργούν, έχουν αδειοδοτηθεί ήδη 165 ανεμογεννήτριες και έρχονται και άλλες. Περισσότερες από 1000 ανεμογεννήτριες αναμένουν να υποβληθούν για αδειοδότηση.
Η Θράκη έχει πάρα πολύ μεγάλη σημασία για τη βιοποικιλότητά της, σε εθνικό και διεθνές επίπεδο. Εδώ συγκεντρώνεται ένας τεράστιος αριθμός ειδών που μπορεί κανείς να συναντήσει σε όλη την υπόλοιπη Ευρώπη. Πολλά από αυτά τα είδη είναι συνυφασμένα με την ανθρώπινη παρουσία.
Ο άνθρωπος στην ευρύτερη περιοχή της Θράκης ζούσε αρμονικά για πάρα πολλά χρόνια στο φυσικό περιβάλλον. Το έχει διαμορφώσει αυτό το φυσικό περιβάλλον. Ο παραδοσιακός τρόπος ζωής με την παραδοσιακή κτηνοτροφία, με τον τρόπο που ασκούταν, έχει οδηγήσει στην ποικιλομορφία του τοπίου, των βιοτόπων της περιοχής, με αποτέλεσμα να προσελκύει πάρα πολλά είδη αρπακτικών πουλιών.
Η προστασία αυτών των πουλιών είναι στόχος για την πολιτεία. Αποτελεί μια δέσμευση. Πρέπει να τα προστατεύσουμε και έχουμε χρέος να διατηρήσουμε αυτή τη φυσική κληρονομιά και να την περάσουμε στις επόμενες γενιές.
Όμως τον ίδιο αέρα που παράγει το ηλεκτρικό ρεύμα μέσω των αιωλικών, τον χρησιμοποιούν και τα αρπακτικά πουλιά που οι κάτοικοι εδώ τα λένε καρτάκια. Και φυσικά όταν συμπίπτει τέτοιας κλίμακας ανάπτυξη αιωλικών πάρκων σε μια περιοχή με τόσο μεγάλους πληθυσμούς, δημιουργούνται και τα ανάλογα προβλήματα. Ιδιαίτερα η θνησιμότητα των πουλιών και των νυχτερίδων που προσκρούν στις φτερωτές των ανεμογεννητριών και ο κατακαιρματισμός και η υποβάθμιση των μοναδικών φυσικών τοπίων της Θράκης.
Έχουν καταγραφεί 26 αρπακτικά πουλιά νεκρά λόγω πρόσκλησης σε ανεμογεννήτριες. 14 από αυτά είναι γήπες, μαυρόγηπες και όρνια. Πολλά πουλιά μικρότερων ειδών και εκατοντάδες νυχτερίδες.
Σίγουρα ο αριθμός των περιστατικών που καταγράφεται δεν είναι και ο αριθμός των περιστατικών που πραγματικά συμβαίνουν. Υπολογίζουμε ότι ο αριθμός των περιστατικών είναι πολύ μεγαλύτερος, γιατί δεν μπορεί να βρίσκουμε όλα τα πουλιά που πάνε στις ανεμογεννήτριες.
Ακόμα και η απώλεια ενός ατόμου από ένα είδος είναι κάτι το οποίο δεν μπορούμε να το αποδεχτούμε σαν πολιτεία και σαν κοινωνία.
Και φυσικά όταν χωροθετούνται τόσες πολλές ανεμογεννήτριες σε αυτή την κλίμακα, σε τόσο σημαντικές περιοχές για τα πουλιά, αυτά πολλές φορές το αντιλαμβάνονται σαν κάποιο κίνδυνο και ή παύουν τελείως να χρησιμοποιούν μια περιοχή ή τη χρησιμοποιούν με λιγότερη ένταση. Ταυτόχρονα μεγάλες σειρές ανεμογεννητριών σε ράχες μπορούν να δημιουργήσουν φραγμούς στις μετακινήσεις τους, για παράδειγμα από τη φωλιά τους, στους χώρους όπου τρέφονται. Και κάθε έργο προσθέτει νέες επιπτώσεις σε μια ήδη επιβαρημένη από τα αιωλικά περιοχή, οι οποίες πρέπει να εξετάζονται ως προς την συνολική επιβάρυνση που ήδη υπάρχει και που προσθέτουν.
Για τις επιπτώσεις λοιπόν από πρόσκρουση υπάρχουν ειδικά συστήματα αυτοματοποιημένου εντοπισμού των πουλιών και πάυσης λειτουργίας της ανεμογεννήτριας.
Σε αυτό μπορούμε να πούμε πρώτον ότι δεν εφαρμόζεται από όλες τις εταιρείες, ενώ υπάρχει σαν όρος δεν εφαρμόζεται και δεν έχει μπει σε όλες τις ανεμογεννήτριες, ενώ πρέπει να μπει το αυτοματοποιημένο σύστημα αποφυγής πρόσκρουσης. Και το δεύτερο είναι ότι παρόλο που χρησιμοποιείται σαν λύση για κάθε πρόβλημα που μπορεί να δημιουργηθεί ανάμεσα σε ανεμογεννήτριες και αρπακτικά πουλιά, δεν είναι. Ήδη μόνο φέτος είχαμε περίπου, αν θυμάμαι καλά, 2 αρπακτικά πουλιά, ένας μαυρόγυπας και ένας φυκιάρης, τα οποία προσέκρουσαν σε ανεμογέννητρες, το οποίο ήταν εγκατεστημένο σύστημα αποφυγής πρόσκρουσης. Την τελευταία δεκαετία έχουν γίνει πολλές τροποποιήσεις στον νόμο για την αδειοδότηση των συγκεκριμένων έργων. Τις περισσότερες φορές αυτές οι τροποποιήσεις μεταξύ άλλων είχαν και αλλαγές όσον αφορά τα χρονικά διαστήματα στα οποία πρέπει να ανταποκριθεί κάθε υπηρεσία για να γνωμοδοτήσει. Τα χρονικά διαστήματα αυτά περιορίζονται και μειώνονται κάθε φορά, με αποτέλεσμα, αν το συνδυάζουμε αυτό και με την υποστελέχωση που υπάρχει στις υπηρεσίες τα τελευταία χρόνια, να γίνεται πολύ δύσκολη η δυνατότητα που έχει κάθε υπηρεσία να ανταποκρίνεται εντός των χρονικών περιορισμών που θέτει ο εκάστοτε νόμος.
Υπάρχει λύση. Τα πουλιά και τα αιωλικά μπορούν να συνυπάρξουν στη Θράκη με σωστή και προσεκτική χωροθέτηση. Τα έργα που μας έχουν έρθει για γνωμοδότηση το τελευταίο έτος, το 65% των γνωμοδοτήσεών μας ήταν θετικές. Ήταν σε περιοχές στις οποίες θεωρήσαμε ότι δεν θα δημιουργηθούν σοβαρά προβλήματα αν ληφθούν τα απαραίτητα μέτρα που προτείναμε, και μόνο σε ένα 35% περίπου ήμασταν αρνητικοί, και αυτό γιατί σε εκείνες τις περιπτώσεις οι περιοχές στις οποίες προτείνονταν να γίνουν τα έργα ήταν ιδιαίτερα ευαίσθητες, με σημαντική παρουσία απειλούμενων ειδών.
Ο Εύρος και η ευρύτερη περιοχή της Θράκης είναι ένα ζωντανό παράδειγμα στο οποίο ο άνθρωπος έχει συνυπάρξει με την πανίδα και τη χλωρίδα της περιοχής τουλάχιστον τον τελευταίο αιώνα. Νομίζω το ίδιο μπορεί να συμβεί και με τα αιωλικά πάρκα που εγκαθίσταται στην περιοχή.
Για την καταπολέμηση της κλιματικής αλλαγής, στόχος είναι περισσότερες ανανεώσιμες πηγές ενέργειας, και τα αιωλικά πάρκα έχουν ένα μεγάλο μερίδιο σε αυτό. Η Θράκη έχει πολύ αέρα. Έχει χαρακτηριστεί μάλιστα σαν περιοχή αιωλικής προτεραιότητας για την εγκατάσταση αιωλικών πάρκων.
Τα τελευταία 15 με 20 χρόνια έχουν εγκατασταθεί πάρα πολλές ανεμογεννήτριες στον Εύρο και γενικότερα στη Θράκη, με αποτέλεσμα σιγά σιγά να αρχίζει να υφίσταται μια πίεση τόσο στο περιβάλλον όσο και ακόμα και στο ανθρωπογενές περιβάλλον, γιατί αρχίζουν και καθίστανται πλέον και γύρω από τους οικισμούς.
Σε αυτή τη μικρή περιοχή του Εύρου και της Ροδόπης, επιπλέον των 276 ανεμογεννητριών που έχουν ήδη κατασταθεί και λειτουργούν, έχουν αδειοδοτηθεί ήδη 165 ανεμογεννήτριες και έρχονται και άλλες. Περισσότερες από 1000 ανεμογεννήτριες αναμένουν να υποβληθούν για αδειοδότηση.
Η Θράκη έχει πάρα πολύ μεγάλη σημασία για τη βιοποικιλότητά της σε εθνικό και διεθνές επίπεδο. Εδώ συγκεντρώνεται ένας τεράστιος αριθμός ειδών που μπορεί κανείς να συναντήσει σε όλη την υπόλοιπη Ευρώπη. Πολλά από αυτά τα είδη είναι συνυφασμένα με την ανθρώπινη παρουσία.
Ο άνθρωπος στην ευρύτερη περιοχή της Θράκης ζούσε αρμονικά για πάρα πολλά χρόνια στο φυσικό περιβάλλον. Το έχει διαμορφώσει αυτό το φυσικό περιβάλλον. Ο παραδοσιακός τρόπος ζωής με την παραδοσιακή κτηνοτροφία, με τον τρόπο που ασκούντανε, έχει οδηγήσει στην ποικιλομορφία του τοπίου, των βιοτόπων της περιοχής, με αποτέλεσμα να προσελκύει πάρα πολλά είδη αρπακτικών πουλιών.
Η προστασία αυτών των πουλιών είναι στόχος για την πολιτεία. Αποτελεί μια δέσμευση. Πρέπει να τα προστατεύσουμε και έχουμε χρέος να διατηρήσουμε αυτή τη φυσική κληρονομιά και να την περάσουμε στις επόμενες γενιές.
Όμως τον ίδιο αέρα που παράγει το ηλεκτρικό ρεύμα μέσω των αιωλικών, τον χρησιμοποιούν και τα αρπακτικά πουλιά που οι κάτοικοι εδώ τα λένε καρτάγια. Και φυσικά όταν συμπίπτει τέτοιας κλίμακας ανάπτυξη αιωλικών πάρκων σε μια περιοχή με τόσο μεγάλους πληθυσμούς, δημιουργούνται και τα ανάλογα προβλήματα. Ιδιαίτερα η θνησιμότητα των πουλιών και των νυχτερίδων που προσκρούν στις φτερωτές των ανεμογεννητριών και ο κατακαιρματισμός και η υποβάθμιση των μοναδικών φυσικών τοπίων της Θράκης.
Έχουν καταγραφεί 26 αρπακτικά πουλιά νεκρά λόγω πρόσκλησης σε ανεμογεννήτριες, 14 από αυτά είναι γήπες, μαυρόγηπες και όρνια, πολλά πουλιά μικρότερων ειδών και εκατοντάδες νυχτερίδες.
Σίγουρα ο αριθμός των περιστατικών που καταγράφεται δεν είναι και ο αριθμός των περιστατικών που πραγματικά συμβαίνουν. Υπολογίζουμε ότι ο αριθμός των περιστατικών είναι πολύ μεγαλύτερος, γιατί δεν μπορεί να βρίσκουμε όλα τα πουλιά που χτυπάνε στις ανεμογεννήτριες.
Ακόμα και η απώλεια ενός ατόμου από ένα είδος είναι κάτι το οποίο δεν μπορούμε να το αποδεχτούμε σαν πολιτεία και σαν κοινωνία.
Και φυσικά όταν χωροθετούνται τόσες πολλές ανεμογεννήτριες σε αυτή την κλίμακα, σε τόσες σημαντικές περιοχές για τα πουλιά, αυτά πολλές φορές το αντιλαμβάνονται σαν κάποιο κίνδυνο και ή παύουν τελείως να χρησιμοποιούν μια περιοχή ή τη χρησιμοποιούν με λιγότερη ένταση. Ταυτόχρονα μεγάλες σειρές ανεμογεννητριών σε ράχες μπορούν να δημιουργήσουν φραγμούς στις μετακινήσεις τους, για παράδειγμα από τη φωλιά τους, στους χώρους όπου τρέφονται. Και κάθε έργο προσθέτει νέες επιπτώσεις σε μια ήδη επιβαρημένη από τα αιωλικά περιοχή, οι οποίες πρέπει να εξετάζονται ως προς την συνολική επιβάρυνση που ήδη υπάρχει και που προσθέτουν.
Για τις επιπτώσεις λοιπόν από πρόσκρουση υπάρχουν ειδικά συστήματα αυτοματοποιημένου εντοπισμού των πουλιών και πάυσης λειτουργίας της ανεμογεννήτριας.
Σε αυτό μπορούμε να πούμε πρώτον ότι δεν εφαρμόζεται από όλες τις εταιρείες, ενώ υπάρχει σαν όρος δεν εφαρμόζεται και δεν έχει μπει σε όλες τις ανεμογεννήτριες, ενώ πρέπει να μπει το αυτοματοποιημένο σύστημα αποφυγής πρόσκρουσης. Και το δεύτερο είναι ότι παρόλο που χρησιμοποιείται σαν λύση για κάθε πρόβλημα που μπορεί να δημιουργηθεί ανάμεσα σε ανεμογεννήτριες και αρπακτικά πουλιά, δεν είναι. Ήδη μόνο φέτος είχαμε περίπου, αν θυμάμαι καλά, 2 αρπακτικά πουλιά, ένας μαυρόκηπας και ένας φυκιάρης, τα οποία προσέκρουσαν σε ανεμογέννητρες, το οποίο ήταν εγκατεστημένο σύστημα αποφυγής πρόσκρουσης. Την τελευταία δεκαετία έχουν γίνει πολλές τροποποιήσεις στον νόμο για την αδειοδότηση των συγκεκριμένων έργων. Τις περισσότερες φορές αυτές οι τροποποιήσεις μεταξύ άλλων είχαν και αλλαγές όσον αφορά τα χρονικά διαστήματα στα οποία πρέπει να ανταποκριθεί κάθε υπηρεσία για να γνωμοδοτήσει. Τα χρονικά διαστήματα αυτά περιορίζονται και μειώνονται κάθε φορά, με αποτέλεσμα, αν το συνδυάζουμε αυτό και με την υποστελέχωση που υπάρχει στις υπηρεσίες τα τελευταία χρόνια, να γίνεται πολύ δύσκολη η δυνατότητα που έχει κάθε υπηρεσία να ανταποκρίνεται εντός των χρονικών περιορισμών που θέτει ο εκάστοτε νόμος.
Υπάρχει λύση. Τα πουλιά και τα αιωλικά μπορούν να συνυπάρξουν στη Θράκη με σωστή και προσεκτική χωροθέτηση. Τα έργα που μας έχουν έρθει για γνωμοδότηση το τελευταίο έτος, το 65% των γνωμοδοτήσεών μας ήταν θετικές. Ήταν σε περιοχές στις οποίες θεωρήσαμε ότι δεν θα δημιουργηθούν σοβαρά προβλήματα αν ληφθούν τα απαραίτητα μέτρα που προτείναμε, και μόνο σε ένα 35% περίπου ήμασταν αρνητικοί, και αυτό γιατί σε εκείνες τις περιπτώσεις οι περιοχές στις οποίες προτείνονταν να γίνουν τα έργα ήταν ιδιαίτερα ευαίσθητες, με σημαντική παρουσία απειλούμενων ειδών.
Ο Εύρος και η ευρύτερη περιοχή της Θράκης είναι ένα ζωντανό παράδειγμα στο οποίο ο άνθρωπος έχει συνυπάρξει με την πανίδα και τη χλωρίδα της περιοχής τουλάχιστον τον τελευταίο αιώνα. Νομίζω το ίδιο μπορεί να συμβεί και με τα αιωλικά πάρκα που εγκαθίσταται στην περιοχή.
Good morning. Perfect. Thank you. Hello and good morning and welcome to everyone to today's event. I'm Konstantinos Yarikos. I'm coming from WWF Greece and also a member of the Society for the Protection of Biodiversity of Thrace, and I'll be your host for this morning. A few introductory words about why we're here today. The Society for the Protection of Biodiversity of Thrace is a kind of newly established local organization in Thrace. It has its center in the Dadia village in central Evros, and it was established 3 years ago. It is kind of the continuation of the work done by many organizations, many national organizations in the wider region of Thrace and Eastern Macedonia. a hotspot region for biodiversity in Greece and in Europe, a very important area for birds of prey, but not only for birds. So the society was established 3 years ago with a strategic focus on the protection of endangered bird species, especially raptors. But not only that, also with a focus in protecting the viable habitats of the area and the landscapes that are important both for birds and the biodiversity overall, and of course for local societies and people. Through the years of working in this region, what we know is that one of the most important threats birds of prey face is the development of renewable energy sources, and especially wind farms. As we heard on the video before, wind farms are, of course, a very important part of the equation of increasing renewable energy sources around the world and in Greece. But at the same time, they do come with a toll on nature when they are not sited in a careful manner. The region of Thrace is a wind farm development priority area for the Greek government, and during the past years we have seen almost 300 wind turbines being installed in the area. These have brought very important cumulative effects on bird populations. But despite that, each wind farm still is evaluated, its siting is evaluated as per the impacts of the particular wind farm, and not taking into account the cumulative effects it has along with all the other wind turbines already in place. So that's what the reason. One of the first priorities of the society was to develop an initiative exactly to evaluate this cumulative effect and produce the kind of guidance to the Greek government and services and permitting services as to how we should proceed in the future with the development of renewable energy in the region. So last year we had 6 studies been concluded on the matter. They included everything from an analysis of the legal framework to an analysis of the processes of the permit procedures and how the terms of the permit procedures are upheld once the turbines are in place, and then a number of studies looking at the impacts of specific species and habitats. So the aim of today's event, of today's discussion, is exactly to present to you and discuss the conclusions of these 6 studies. On the typical side of the matter, let me mention that this whole work was supported in the framework of a wider national initiative taken by WWF Greece for the protection of iconic species in the country, an initiative that brings together more than almost 10 national NGOs to work on flagship species and flagship issues for their protection. And as I said, the aim of these studies was exactly to fill in a knowledge gap and produce guidance for Thrace primarily, but then guidance that can be replicated, can be taken further to other sites, because this is not a problem just of Thrace. This is a problem we are facing in many places around the world, and we need to find a solution to reconcile our urgent need to face the climate crisis with our equally urgent need to preserve the world's biodiversity. On the methodological side of the studies, we need to mention that what you will be hearing today is 5 out of the 6 studies that were implemented separately and independently. So you might see slight differences in the number of wind farms they refer to or the number of wind parks they refer to. That's because maybe each of the researchers was based on a slightly different period or on a slightly different data set about the renewable energy analyzed. Now, on the house rules for this morning, we will, as I said, we will hear 5 presentations in the agenda that has been shared with you. There were 6 presentations. There was one starting presentation that had to do with the legal framework in Greece. We had a long discussion about that issue. We had a long of questions yesterday when we ran the same presentations for the Greek crowd, and we decided that this was a presentation not really relevant to an international audience. So we decided not to have this presentation today, so to leave more space for discussion. So 5 presentations, roughly 15 minutes each, and then some space for questions. Participants cannot raise your hands. You cannot raise your hands. You cannot open your microphone, so you cannot intervene live in the discussions. If you have questions, you should be writing them in the Q&A tab, which is on the bottom of your Zoom window next to the participants and the chat and everything. You'll see a Q&A tab. That's where you can write your questions. We have a back office team that will be filtering the questions, grouping them, and then passing them on to me and the speakers for answers. The discussion for the economy of time is not open to interventions and opinions. We are sorry for that, but we needed to have a compact program so that everybody can follow the whole of the discussion. If specific opinions or interventions are written in the Q&A or in the comments, we will be recording them. We will be keeping them in record to enrich our communication, our further work on the matter, but they will not be discussed today. So this is a framework and our rules. We can directly move to the first presentation. We have with us Dr. Eleftherios Kakalis. Dr. Kakalis is a forester and ornithologist who has been working on research projects and conservation projects for many years, and he has done some very interesting work that has to do with the permit system and how the different terms put on companies are then upheld during the operation of the wind farm. Eleftherios, the floor is yours.
Thank you for your good words. I'm not a doctor, but I'm still trying to. I have a lot of experience on bird monitoring and programs and evaluation of studies and doing studies. So I will go. I would like to say thanks to the Society of the Protection of Biodiversity in Thrace for this opportunity to present my work. And let's go straight to my presentation. Is it okay? So our study was to examine the examination of environmental terms and the evaluation of the appropriate assessments and monitoring programs for the wind farms in Thrace. So the study was divided in 5 sections. The first section was about the status of the wind farms in Thrace. The second was about the analysis of the environmental conditions approval decisions. The third section was about the analysis of the primary data from the monitoring programs. And the fourth section was about the evaluation of the studies. And the fifth and the last was about drawing conclusions and making recommendations. So today I will focus on the third section. I will present, because I'm the first presenting, the first panelist. So I will describe the status more or less in Thrace about the wind farms, but I will focus in the analysis that we made in primary data. So the wind farm development in Thrace, it has steadily increased from 2001 until today. 62% of the existing wind turbines are located in the Natura 2000 network. while 97% of the turbines are within the important bird areas. There is a high investment interest for the future, for new farms to be installed. So the technical characteristics of the existing wind turbines show a great variability in nominal power, rotor diameter, and the tower height. And installing new wind turbines is expected to increase the diversity and the dangerous collision zone for vulnerable bird species. So the studies should invest all these changes through the time. Let's go to the data that we gather from the studies. And the first, we should discuss the distribution of the most important species in Thrace based on the studies dataset. The black vulture and the griffon vulture and the golden eagle, we can say they are present almost everywhere in the area. We tried to build an index based on the data of the studies. So we calculated or estimated the flights per 10 hours in danger zone of the wind farms where possible. So the data set for the black vulture and griffon vulture is presented. And we can say that there is a very high spatial coherence for these two vulture species, the black and the griffon vultures in the area. So after that, we estimate the cumulated flight index for vultures, and the low values of the index goes in the peripheral areas of Rhodope area. It's this area here, if you see my cursor, in this area. While high index values was placed in the central area, mountainous area of Rhodope prefecture, is this area. And the most wind farms placed in Evros prefecture, this area, if you see my cursor. The collisions we have, vulture collisions we have in Thrace are in spatial coherence with this cumulative flight index. And I should say that there are important information gaps for many wind farms coming from inappropriate studies. If you see the question marks and the gray areas, data is missing here. So we cannot estimate the flight index for these areas. The gray zone, the gray wind farms. So we try to analyze the data coming from automated bird collision avoidance systems. So we had available data for 3 wind farms, and we calculated the percentage of flight that resulted in rotor stoppage to avoid collision in the turbine. So let's say low percentage values should indicate high levels of turbine avoidance by birds, and high percentage values should indicate low levels of that avoidance by birds, despite the activation of warning sounds of the automated systems. And the result is in this diagram. Sorry that it's in Greek, but I will explain you For example, the high values, the high percentage we have for black vulture is 47% for black vulture. Short-toed eagle has high values, black stork also, and griffon vulture. So we can say that about half of the black vulture and 1/3 of griffon vulture flights that trigger the systems resulted in rotor stoppage to avoid a collision. And until the end of last year, there were 2 incidents of collision with wind turbines equipped with automated system, one involving a black vulture and one involving a booted eagle. So have in mind that after we produce this index, the flight index per 10 hours, and we have this percentage of light resulting to a rotor stoppage, we estimated for 5 different scenarios of vulture presence on an annual basis, the expected cases that would result in rotor stoppage in the wheat farms for 1 year. So we create this. The x-axis is the flight index, and we are showing the number of the expected cases that would result in a rotor stoppage. And we compare these scenarios that we made with actual data coming from the wind parks with automated systems. So the area in the red box is the actual data, and these cases of rotor stoppage involving vultures per wind turbine for the year 2020. And in the right side of the figure is the scenarios that we made based on the flights per 10 hours in Zone A, the danger zone. This is coming from the pre-construction environmental study dataset. The first conclusion that we can say that based on the wind turbine of this wind farm named Grammatikaki and the wind farm number 7, the data is in accordance with the scenario of 115 days of vulture presence in the danger zone. And the second conclusion, we can say that it was probable to estimate this high risk of collisions with the appropriate analysis of the data, making different scenarios in the pre-construction study. So here I will present, this is the same wind farm, and this is the total cases of rotor stoppage involving vultures in the wind turbines in 2020. A lot of cases for black vulture, also for griffon vulture, and 1 case for Egyptian vulture. The flight index was about 1.76 flights of vultures per 10 hours in Zone A. The second wind farm that we analyzed, the cases were lower, but we had 175 cases of black vulture, and the index was lower of the flight index. So the question is what was the appropriate assessment of the collision risk for the vultures in these cases? So we present the flight index for black vulture, And we present only the pre-construction studies. And down you see the significance of the assessment for collision risk. And this is the two cases here in the red box of the wind parks that was presented in the last slide. And the first strange thing is that the assessment was the same. It was low to medium significance or low to medium effects for collision risk. And the other thing that is quite strange, I can say, is that the low significant effects should have low values for the flight index and again the high level of the effects should have high values of the index. So this is not happening for black vulture, and it's not happening for griffon vultures. We have a lot of assessments that somehow they are not related with the index, the flight index. So our conclusion is this. This is quite strange what happened. So the collision risk for vulture species was not assessed as being of high significance in any of studies. So these assessments are questioned by the high index values of the vulture flights in Zone A for at least 7 wind farms. If we see the grammatikaki in the figure in the center, there are a lot of other wind farms with higher flight index values, and we consider these wind farms to have the same results as the grammatikaki wind farm. And we also, the collision assessments are questioned by the statistics of the operating automated systems, the known vulture collisions in the area, we have 14 cases, and the large information gaps for many wind farms. So we can say with confidence that in several wind farms in Thrace, there are numerous improperly placed wind turbines, that the exact number of them or quantity of which remains unknown. So all the cases presented in the previous slides is coming mainly from pre-construction studies. And the pre-construction studies were evaluated as the most comprehensive studies in the assessment we conducted. The post-construction studies were evaluated lower due to significant methodological deficiencies in various parameters. For example, talking about the post-construction studies, the collision risk was not estimated for 54% of the studies. The cumulative effects were not estimated for 62%. The data from the automated system monitoring was not compared with the monitoring coming from the vantage points. The bird mortality was estimated by indices per wind turbine in only 15% of studies. And I'm coming to some of our basic proposals as a matter of the wind parks with automated belt collision avoidance systems, we should make an evaluation of the effectiveness of automated systems, mainly to study how effective it is to vultures or to large raptors. We need to make studies need to make a comparison of the monitoring results coming from the automated systems and with the other monitoring methods. In the studies, there were only a few cases that in the studies that they made that. So for some reasons, we should do it. So about bird monitoring programs in pre and or post-construction studies, we need to use reference sites. The experimental design of these studies is not using a batch experimental design, and we should do it. And we should use the same scientific objectives and methodologies in pre and post-construction studies, and mainly to estimate collision risk or cumulative effects. The collision risk should be estimated per wind turbine and not for the whole coverage zone of the wind park. The majority of the studies were estimated, were making estimates for the whole coverage zone of the wind parks and not per wind turbine. And we need an adaptation of specific protocols and analysis guidelines for primary data analysis for the studies. And we propose the creation of an open access dataset containing all the raw data per method and the significant findings from each study. So that's all. Thank you.
Thank you very much, Lefteris, Mr. Kakalis, for this very interesting presentation. And I have a question here on what you presented, that is whether the results of these post-monitoring reports and the automated system reports, which we understand they have some deficiencies, they have many deficiencies, but still they produce a data set that is very useful if analyzed correctly, whether these results are actually used in practice by the services. Are the permits procedures or the permits, the terms they impose on new developments educated or updated according to the results we have from all these post evaluations?
First of all, they should the data that this monitoring produce should be analyzed by the environmental consultants that they are doing the studies. The majority of them, or in the studies, they just take the report from the company that is producing this data, and they don't analyze them. They don't compare the data. So first of all, the environmental consultants should use this data and analyze the data. They don't do it.
Okay, I see. Is what you're saying is that we also need some kind of more independent evaluations of the data, because we're now based exclusively on what the companies say about these post studies?
I really don't know. I'm not sure, because this data, they should use this data and analyze this data. We don't need something to be independent or It's a good idea for the quality of the studies, but they should, the environmental consultants should do it. They don't do it, and there is a lack of a gap of information here, or a gap of in the procedures that of doing these studies, in doing these studies.
Very clear. And I have a second question, which is what kind of automated bird collision avoidance systems have been installed in the parks?
The majority is DT bird.
Okay.
System. For the majority of the wind park.
Okay. Thank you very much. So I think this wraps it up, and we can move to the second presentations. Many thanks, Mr. Kakalis, also for keeping up with the time. We're doing well on that sector. So we are moving on to the second presentation that has elaborates on a different type of impact that has to do with the impact of the actual installation of wind farms on the land use and the land cover. We have with us two speakers today on that subject. Dr. Fotis Xistrakis, who is a researcher, a phytosociologist in his expertise and a researcher at the Institute for Forestry Research, and Dr. Christos Damianidis, who is also a forest researcher with many years of experience in phytosociological research and mapping. So, gentlemen, the floor is yours.
Good morning from our side.
Good morning.
Let's go to screen share. And we go here. So, thank you for the introduction. We will try to assess and describe our methodology and our results regarding the impact of the construction of wind farms and the also the construction of the roads that facilitate the construction and the operation of the wind farms in the land cover and the land uses of our study area. So the aim of this study, first of all, is the assessment of the extent of intervention, how much surface area has been destroyed from the construction of the wind farms and the roads. And the second part is also the assessment of which type of land cover has been affected by this construction, and not only in terms of land cover, but also in terms of the habitat types of the Habitats Directive, this 92/43 directive, which is also my specialty. So the presentation will be divided in two parts. The first part regarding the methods we followed will be held by Christos Damianidis, and the second part with the results is going to be my turn. Okay, so.
Okay, about the methodology that we follow, the study area includes 10 municipal units of 5 municipalities of Evro and Rhodope regional units that located in Eastern Macedonia, Thrace region, as we can see in the map. It includes 36 wind farms that are licensed for production, installation, or operation, in which the 332 wind turbines have been or will be installed in the future. About the methodology now, we have the two sections. The first section has to do with the existing wind turbines. We make a detailed mapping of deforestation and distribution of disturbance of natural vegetation as a direct consequence of all intervention that took place. The second section has to do with wind turbines that are in procedure of installation. For those turbines, we have make a estimation, 50 meters, a circle of radius of 50 meters. And we choose the center that was proposed from the data that was provided from the RAE website. About the network, the road network, we create two linear shapefile. The one was about the 1996. We have aerial photo for this period that the installation has not started. And the second linear shapefile was for from the satellite image of 2021. So we create two linear shapefiles for this period that I was told. After the creation of this linear shapefile, we take for each road, for each period, a width of the road, as we can see in the image on the right. We take the width of 2000 of the two periods, and we create a polygon shapefile, both for 1996 and 2021. The two polygons of the year 1996 were spatially abstracted, the spatial difference between the two periods, from the road polygons of the year 2021. There are some cases that there was no roads in 1996, so this polygon that was produced from the abstraction has to do with a new road network. So, about the vegetation now, we have created 4 land cover classes about grasslands, shrublands, forest, and anthropogenic or other uses. The classification, the classes was identified by visual interpretation in the historical area photos, and the overlap between the two periods, as we made it in the road network on mapping, demonstrate the change in land use due to the construction of installation sites of wind turbines, and also for the combining facilities, as well as the opening or widening the road network, servicing the wind farms. After we have finished this procedure, we assigned these areas in habitat types of the national or union interest, Directive 9243. And the assignment was made after we made some field visits in order to identify the habitat types in the field. Okay. Results now.
It's my turn now. Thank you. So, having followed this methodology, we actually concluded that in the total 332 wind turbines that have been installed, there was a total area of 126 hectares that was actually an intervention for the in the 36 wind power stations. 55 of these wind turbines are located in wind power plants, in wind farms, which have not been yet constructed. So this area is yet to be intervened from the constructions. There was also an addition of 54.62 hectares that was actually an intervention and destruction of natural habitats from the construction or the widening of the road network. So that makes a total surface area of 181.50 hectares. And most of the most of these wind farms are located in the municipality of Ariani, with more than 50% of this area. So, regarding the time allocation of these interventions in the natural land cover, we see that from, forgot to mention that we take this data from the RAE website. So it means that when we consider the time of construction that was provided from the wind farms. Okay, so from the period of 2002 to 2007, we can see that there is an intense construction activity. Then there is somehow a pause from the period of 2007 to 2016. And then from the last 5 years, we have again an increased activity. 50% of the total area from the intervention of the wind turbines locations has already been done since 2009. So it's quite old story. And yet there is 25% of the area that is yet to be constructed. So these are for these wind turbines that they haven't been installed yet. Regarding this percentage, I have to say that maybe considering this 50 meters radius for the estimation of the total surface area of the new constructions, maybe it's too much, because we've seen that the average of the existing wind turbine installation sites is a little bit less than this. But if we consider that the rotors are getting bigger and bigger, and if we also consider that there is no estimation of the new roads that will be constructed for these new wind turbines, we consider that this is a very good approximation of a real surface area that will be impacted. Regarding the land use and land cover of the site, we realized that the largest part of the total surface area actually refer to grasslands, and this is normal because the wind turbines are built along the ridges, and along the ridges grasslands dominate, at least in the study area. But there is also a large part that refers to natural forests, and usually and mostly these are forests of broad-leaved species that includes mainly quercus, oaks, and some part of beech fungus forests. There is a small part that impacts land cover of conifer species, and this is mainly Pinus brutia forest that we find in the area. And I have to say that in these 2.21 hectares in the conifer species, in the conifer forest, reforestations are not included, so we talk about natural forests here. Regarding the habitat types, we realized that the interventions took place in 6 habitat types of community interest, in 1 habitat type of national interest, and 2 habitats which are related with human-induced and man-made uses. In forest habitat types, the intervention took place mainly in broadleaf species, in the forest of broadleaf species. That includes the habitat type 91M0, that includes all the broadleaf oak forests of the area. And regarding the conifers, the habitat type is the 9540, that includes all natural Pinus brutia forests of the area. Again, reforestations are not included here. As I said, the majority of interventions took place in grassland habitat types. Unfortunately, for the study area, we cannot really distinguish which of the habitat types, of the grassland habitat types that may occur in the study area were impacted. But this is somehow serious because one of the grassland habitat types is a priority grassland habitat type, this is 6220, and the other is yet a habitat of community interest, but not a priority. But this has to be resolved. But the only way to conclude which habitat type was impacted, we need some vegetation sampling during basically vegetation sampling to describe correctly and appropriately the vegetation. Regarding the roads, we can say that the pattern of impacts is more or less the same, like the installation sites of wind turbines. Roads mostly affected grasslands, then forests, and then scrublands. And as we see here also with the combined results in the graphs on the right side, we see that the pattern and the impacted sites, the impacted surface area is analogous and is directly respective to the surface area that was impacted for the wind turbine installation sites. So regarding the cumulative impacts, we have an abstracted consideration of the intervention from the construction of installation sites and roads for each wind farm. That actually hides, in my opinion, the cumulative impacts over broader geographical areas, and this has to be taken into consideration. The estimation of cumulative impacts, we believe that must be fair to specific geographical units of standardized surface area. And so the results are comparable when actually we try to compare how much has been affected in each of these geographical units with the next or the other similar geographical units in the same area. And of course, the use of these standardized geographical units also give us an opportunity for a standardized methodology to estimate this impact, this cumulative impact. We consider that European reference grid, which is the grid of 10 by 10 kilometers or less, can be used as a reference spatial unit, because this is actually the spatial unit which area and range of habitat types and species for the assessment of the area and the range of the habitat types and the species of the habitats directive is used, also for the birds directives, if I'm not wrong. And I think we should start discussing of proposing a certain threshold of the total surface area of interventions that they are allowed to take place within a grid cell. That has to do with a total of surface area within the grid cell, a threshold of total surface area impacted within the natural land cover of each grid cell, because you can realize that each of these grid cells, this 10 by 10 kilometers, may include also settlements, may include agricultural land and so on. It's not all natural land cover. Yeah, so just resuming, the estimation of cumulative impacts, actually we see that the installation of wind farms resulted in total of 181 hectares of intervention. 126 of them is in installation sites and 54.62 hectares refer to roads. This 54.6 hectares of roads, it's a quite large percentage. So the impact because of the road construction should not be neglected and should be also considered, seriously considered during the constructions. Interventions took place mainly in grasslands, as it is the dominant land cover type. As I said, there is a certain need to assess if grasslands are assigned to the priority habitat type 6220. And this is more specific because this intervention, this impacts, this change of land cover has to be also related to the national and site-specific conservation objectives for the habitat types and the species. And I say that because there is the new law that there is no, it's not possible to reduce the surface area of a habitat type of a habitat type of community interest. And if you do so, you have to take some measures to restore these habitats. This is not only site specific within each of the Natura 2000 site, but also refers to the national objectives. So within Greece, whatever is destroyed has to be restored somehow. And there is a need to consider a standardized special units for the estimation of cumulative impacts over broader geographical units. Thank you for your attendance, and I hope it was interesting.
Thank you very much to both of you for a very interesting presentation. Accompanying works for wind farms, and renewables in general is a great consideration in Greece. And having an international crowd today, we can mention that it is a very conflictuous issue around Greece, and especially in small islands and areas with strong landscape considerations. I have a question for you, which has to do with whether in your analysis, your estimations, you have also calculated the road embankments on the sides of the roads, downstream and upstream of the roads, as the question is posed, and around the wind turbine bases. And if it was not included, if you have an estimate of the underestimation you may have had of the cleared area.
Let me say some words for you. Okay, about the calculation, we take the polygon that was provided by RAE website, that was a buffer only the construction zone of the wind farm. It was very limited, so we limited only in the borders of these polygons. During the procedure of mapping, we realized that the habitat loss or the land change was much more than this, but we also include in this polygon section, we also include the embankment also. So during the calculation of the width of the road, we calculate the embankment also, but only in the polygon or that provided by RAE website. So the embankment also was much more than these numbers that you all see in our presentation, because the area was very limited. We don't hear you.
Sorry, I was muted. Thank you very much for that answer. And another question we have on the Q&A section has to do with fragmentation. And whether there are, I'll read it as it is, are there any examples of the wider ecological impact of the fragmentation? For example, seed dispersal or wildlife migrations resulting from turbine installation and associated road development. Examples of analysis of this impact. Coming together with a comment, it seems the study may be limited to the analysis of areas directly disturbed. And if so, what recommendations can be made to better understand the broader ecological impact of such developments?
Fragmentation was not taken into consideration because, as I said, our methodology actually was based on the estimation of the area that was impacted within a wind farm. So a wind farm that may include 3, 4, 5, or 6 wind turbines, or more or less, it is actually just a small square, a small spatial unit, taking into consideration the broader geographical area of a municipality or a prefecture. In my opinion, fragmentation has to be considered over broad geographical units, but that was out of the scope of our study. To be honest, I am not sure. I haven't really thought how we can estimate the impacts from fragmentation into the natural habitat types, because I don't really know, and I cannot really understand at this point from what I know and from my background. At this moment, I cannot really understand what is actually the impacts from the fragmentation through the construction of roads into the habitat types. I'm not talking about animals, I'm not talking about plant species, I'm talking about habitat types. Okay, this is my background. So at this moment, with my background, I'm not sure. It has to be done, in my opinion, but I cannot answer how. And certainly it has to be done in over broad geographical areas, not the polygons that we consider, not just the wind farms. Okay, excellent. Thanks a lot. I think we have an open door for another research project of colleagues who can look into this thing. And a final question, which is a bit more factual in nature, is the 6220 grassland priority habitat type the only grassland to take into consideration? Or are there more in Greece or Mediterranean, more priority grassland habitats? For the study area, based on our site visits and based on our knowledge, and based also in the literature review that we conducted, we actually consider all the Natura 2000 sites with mapping and the recording of the habitat types. We realized that the grasslands that they have been mapped and considered were either 62A0 or 6220. Both are very similar. They're both considered as dry grasslands. I suppose, for example, in the Dia forest, I had a recent research and I realized that there is an extra, 2 extra habitat types that occur there. It's possible to have more habitat types, especially when we, but I think the vast majority the vast majority of the grassland consists of these 2 habitat types, at least in the study area there. Good. Thank you very much, Fotis and Christos. Thank you for an excellent presentation and the discussion. And we can move on to our next presentation. It is the last before we have a short break. And I will introduce that on a short personal notice. Many years back when we started looking into the impacts of wind farms on birds and biodiversity in Thrace. Personally, I was really negatively surprised by the impacts these installations had on bats, and that was many years ago. And we did this first assessment together with Dr. Panagiotis Georgakakis, who will also be our presenter for the next presentation. Panagiotis is he's a biologist. He's a bat expert, a prominent bat expert in Greece, and he's a scientific associate of the Natural History Museum of the University of Crete and a member of the IUCN Bat Specialist Group. So, Panagiotis, the floor is yours.
Thank you very much, Konstantinos. As previous presenters said, there are many wind farms in Thrace, and most of them are not studied regarding the impacts on bats, or very poorly studied. The best data set we have is from a study that WWF Greece, WWF Hellas did in 15 years ago, started in 2008 and lasted for 3 years. And I was very honored to participate and analyze together with colleagues mortality data and produce an article published in a journal. And this study was focused in a small percentage of the wind turbines situated in the area. After an exploratory period, only 88 wind turbines were selected, and they were visited 5 or 6 days a week by 2 field workers, which were searching in an area of up to 50 meters radius around each wind turbine. And this lasted for a full year. This is the wind turbines which were searched with black dots in the red frame. But around this, inside this and around this, there are other sorts of turbines regarding the estimations on bat casualty. As I said before, and I'm going to talk about that later on. So for the whole extended period of searches, 192 bats were found dead or injured, alive injured, and they belong to 9 or 10 species. Some specimens were difficult to identify, but you see that most of them are 4 species. In the upper right diagram, you see that most of the carcasses were found in between April and October, but the temporal patterns vary between species. And also, most of the bats, we saw that they were adult males. And it was very interesting to see that there's great variance between wind farms and between specific wind turbines in individual wind farms regarding the number of deaths, the number of bat carcasses, and also species found killed varied greatly between wind farms and turbines. So this initial study left some very intriguing open questions like which are the wind turbine and environmental characteristics that determine the number of deaths? Why is such variance between wind farms and turbines? And second, which is the interaction scale between bat deaths and land cover characteristics? And third, how many bats are actually killed? Because we searched in a small percentage of wind turbines that they were existing and operating, and many more are in the licensing procedure or have been established since then. So the Safe Flyways project, which is funded by BirdLife International and MAVA Foundation, and we're presenting today, gave us the opportunity to try to answer these questions. And we tried some statistical approaches led by Dr. Aristides Moustakas, who is the statistician of the group. And we managed to publish this work recently in a journal, and we're very happy to know that it has a very good acceptance among the scientific community, but also management bodies of protected areas have delivered this study through the coordinating authority and have to take this in account, which is a good step towards evaluating new proposals. What we actually did is to try to analyze the number of deaths regarding wind turbine characteristics like tower height, rotor diameter, and power of turbines, but also the percentage of land use around turbines and distance from water and trees, altitude, slope, and aspect, different landscape characteristics. And we did this on different scales in a radius of 250 meters, 1,000 meters, 5,000 meters, to see which is best explaining the death numbers. And then we extended this to other wind farms not well studied or not studied at all, or not operating yet. We tried different generalized linear models to see which wind turbine characteristics explain deaths better, and so that power is the one that has the best explanatory ability. And also we tried different models regarding the interaction scale, and we found out that at 5,000 meters, landscape characteristics are explaining the number of deaths better. So we used these results to build our final model, and it showed that power, percentage of natural cover, and distance from water are explaining most of the variance regarding number of deaths, and they have the biggest coefficients, positive coefficients, and also they are more robust, as shown by the sensitivity analysis, which shows that the coefficients did not cross 0.95% confidence intervals. And then what we did is to perform an analysis called variance partitioning to actually rank the explanatory variables and see which is best explaining the number of deaths. And this is power, of course, which explains almost 40% of the deaths, and then natural cover and distance from water, as you can see in this diagram. And the last step was to use this model to predict the number of deaths in other wind farm groups, wind farms that are very poorly surveyed by other studies, post-construction surveys with a very limited and poor quality search of carcasses, or wind farms not searched at all. And of course, there's wind farms that are not operating, also licensed, or wind farms that are pending for license. And in total, we estimated that the number of deaths each year exceeds 1,150 bats in this area. And it will be intriguing to extend this to the rest of Greece, but the habitat characteristics variability across the country is very big to go there. So to conclude, wind turbine power is a characteristic that explains best the deaths. So the more power you install, the more damage you do. And the optimal interaction distance between wind turbines is 5,000 kilometers. So the only way to minimize the casualties is to not to place wind turbines close to natural areas, especially forests and water bodies. And the impact assessments should extend the search range from what they do now in a radius of a few hundred meters to a much greater area. And this is supported by other studies that shows that wind turbines attract bats. So if you go before the construction for an EIA to look for bats in the proposed sitting area, this doesn't tell you much, because bats will come when you install the wind turbines, and they will come from a much bigger distance. And we have to have in mind that the estimated deaths are always much fewer compared to the actual ones, because nobody's taking account searcher efficiency, and the removal of carcasses by scavengers. So the problem is even bigger. Well, a usual question is, how big is the problem regarding the effect on the population? And nobody is able to reply to this, because for the species that are usually killed in wind turbines, population estimates are almost impossible, because they roost in trees or rock crevices and cannot count them. They fly at night, as you know, but they are all species with very low reproductive rates. They have one baby per year, high infant mortality, so they are very sensitive to man-made mortality. And that's why there are certain very detailed guidelines in other countries and also in a European level, like the guidelines that has been produced by Eurobats and are translated to Greek and uploaded to the website of the Ministry of the Environment, so they have to be followed. And the results of the assessment have been openly accessible, and they have to be used, because we see sometimes post-construction surveys that say that we found this number of bats, dead bats, but it's small and it's not justified why it's small, or it may say that it's big, but nothing is happening. They're just doing the surveys and write the results, but they are not being used. This is from my side. Thank you for your attention. I don't know if there's any questions to answer.
Thank you very much, Panagiotis, for a really interesting presentation. I have one question for you, which has to do with, the question is, since we know that bats don't fly when we have strong winds, could the requirement for a cut-in speed in wind farms, so that they only operate above a certain level of wind speed, bring a solution, or anyway a slight solution, a minimization of the impact on bats?
This will be my recommendation for existing wind farms. And if we made a rough calculation, the loss for the, let's say, the owner of the wind farm is not that big, because we're talking about certain period of the year, or even certain nights through the warm season, and it's only some hours a day during the night, and mostly a few hours after sunset. So it's not a big deal, but yes, this is one part of the solution. Proper seating is the first and most important, because it's not only mortality, but it's also habitat loss and fragmentation and other things. So yes, establishing a cut-in speed is a very important measure, but not the only thing.
Okay, thank you very much, Panagiotis. I think we don't have any other questions, so I can release you. We will be breaking for a short break, but just before we do that, there was a question a bit earlier that came just a bit late, and we didn't have a chance to answer it, and I think it goes to Lefteris Kakalis. The question had to do with the automated system that we analyzed in the wind farms, and whether this is the automated system of wind turbine. Is it the one that stops the wind turbines when a bird is approaching?
Yeah, this is the system, and when a bird comes toward the wind turbine and trigger the system, there is an activation of warning sounds. I think there are 2 stages of this, and then if the bird continue flying toward the turbine stop. And the main finding of our study is for the vultures, the system stops for the majority or for the half cases for black vulture and for 1/3 of the flights of griffon vulture. So we need to somehow to study this, study the effectiveness of these systems, especially for the vultures.
Excellent. Thanks a lot, Lefteris. So with this answer, we conclude the first part of our discussion. We will take a very short break for bio needs or coffee or whatever. So we will break now and we'll be back starting with our next presentation in 1:30. So that's in 5 minutes from now. So see you all in 5 minutes.
Για την καταπολέμηση της κλιματικής αλλαγής, στόχος είναι περισσότερες ανανεώσιμες πηγές ενέργειας και τα αιωλικά πάρκα έχουν ένα μεγάλο μερίδιο σε αυτό. Η Θράκη έχει πολύ αέρα. Έχει χαρακτηριστεί μάλιστα σαν περιοχή αιωλικής προτεραιότητας για την εγκατάσταση αιωλικών πάρκων.
Τα τελευταία 15 με 20 χρόνια έχουν εγκατασταθεί πάρα πολλές ανεμογεννήτριες στον Εύρο και γενικότερα στη Θράκη, με αποτέλεσμα σιγά σιγά να αρχίζει να υφίσταται μια πίεση τόσο στο περιβάλλον όσο και ακόμα και στο ανθρωπογενές περιβάλλον, γιατί αρχίζουν και καθίσταται πλέον και γύρω από τους οικισμούς.
Σε αυτή τη μικρή περιοχή του Εύρου και της Ροδόπης, επιπλέον των 276 ανεμογεννητριών που έχουν ήδη κατασταθεί και λειτουργούν, έχουν αδειοδοτηθεί ήδη 165 ανεμογεννήτριες και έρχονται και άλλες. Περισσότερες από 1000 ανεμογεννήτριες αναμένουν να υποβληθούν για αδειοδότηση.
Η Θράκη έχει πάρα πολύ μεγάλη σημασία για τη βιοποικιλότητά της, σε εθνικό και διεθνές επίπεδο. Εδώ συγκεντρώνεται ένας τεράστιος αριθμός ειδών που μπορεί κανείς να συναντήσει σε όλη την υπόλοιπη Ευρώπη. Πολλά από αυτά τα είδη είναι συνυφασμένα με την ανθρώπινη παρουσία.
Ο άνθρωπος στην ευρύτερη περιοχή της Θράκης ζούσε αρμονικά για πάρα πολλά χρόνια στο φυσικό περιβάλλον. Το έχει διαμορφώσει αυτό το φυσικό περιβάλλον. Ο παραδοσιακός τρόπος ζωής με την παραδοσιακή κτηνοτροφία, με τον τρόπο που ασκούταν, έχει οδηγήσει στην ποικιλομορφία του τοπίου, των βιοτόπων της περιοχής, με αποτέλεσμα να προσελκύει πάρα πολλά είδη αρπακτικών πουλιών.
Η προστασία αυτών των πουλιών είναι στόχος για την πολιτεία. Αποτελεί μια δέσμευση. Πρέπει να τα προστατεύσουμε και έχουμε χρέος να διατηρήσουμε αυτή τη φυσική κληρονομιά και να την περάσουμε στις επόμενες γενιές.
Όμως τον ίδιο αέρα που παράγει το ηλεκτρικό ρεύμα μέσω των αιωλικών, τον χρησιμοποιούν και τα αρπακτικά πουλιά που οι κάτοικοι εδώ τα λένε καρτάγια. Και φυσικά όταν συμπίπτει τέτοιας κλίμακας ανάπτυξη αιωλικών πάρκων σε μια περιοχή με τόσο μεγάλους πληθυσμούς, δημιουργούνται και τα ανάλογα προβλήματα. Ιδιαίτερα η θνησιμότητα των πουλιών και των νυχτερίδων που προσκρούν στις φτερωτές των ανεμογεννητριών και ο κατακερματισμός και η υποβάθμιση των μοναδικών φυσικών τοπίων της Θράκης.
Έχουν καταγραφεί 26 αρπακτικά πουλιά νεκρά λόγω πρόσκλησης σε ανεμογεννήτριες, 14 από αυτά είναι γήπες, μαυρόγηπες και όρνια, πολλά πουλιά μικρότερων ειδών και εκατοντάδες νυχτερίδες.
Σίγουρα ο αριθμός των περιστατικών που καταγράφεται δεν είναι και ο αριθμός των περιστατικών που πραγματικά συμβαίνουν. Υπολογίζουμε ότι ο αριθμός των περιστατικών είναι πολύ μεγαλύτερος, γιατί δεν μπορεί να βρίσκουμε όλα τα πουλιά που χτυπάνε στις ανεμογεννήτριες.
Ακόμα και η απώλεια ενός ατόμου από ένα είδος είναι κάτι το οποίο δεν μπορούμε να το αποδεχτούμε σαν πολιτεία και σαν κοινωνία.
Και φυσικά όταν χωροθετούνται τόσες πολλές ανεμογεννήτριες σε αυτή την κλίμακα, σε τόσο σημαντικές περιοχές για τα πουλιά, αυτά πολλές φορές το αντιλαμβάνονται σαν κάποιο κίνδυνο και ή παύουν τελείως να χρησιμοποιούν μια περιοχή ή τη χρησιμοποιούν με λιγότερη ένταση. Ταυτόχρονα μεγάλες σειρές ανεμογεννητριών σε ράχες μπορούν να δημιουργήσουν φραγμούς στις μετακινήσεις τους, για παράδειγμα από τη φωλιά τους, στους χώρους όπου τρέφονται. Και κάθε έργο προσθέτει νέες επιπτώσεις σε μια ήδη επιβαρημένη από τα αιωλικά περιοχή, οι οποίες πρέπει να εξετάζονται ως προς την συνολική επιβάρυνση που ήδη υπάρχει και που προσθέτουν.
Για τις επιπτώσεις λοιπόν από πρόσκρουση υπάρχουν ειδικά
Okay, here we are. Thanks a lot. And that was really short, but I hope we're all back and we can start with our next presentation that focuses on the considerations we had where it all started, and that's the impact of the wind farms on the key priority species, on some of the key priority species on these sites. We have with us Lavredis Sidiropoulos. Lavredis is a field ornithologist. He's an expert on raptor ecology, and he has worked for many years in the area, and he's currently conducting his PhD at the University of Ioannina. And Lavredis, you will be giving us a presentation on the effects of wind farm development in the priority species of the scenarios griffon vultures and the golden eagles, the cumulative impacts that is. So the floor is yours. Thank you.
Hello from me too. I will be, Hello from me too. I will be describing the effects of this industrial scale wind farm development has on the three priority species, as Konstantinos said. In particular, we're looking at the cumulative collision mortality and displacement for cinereus and griffon vultures and the golden eagle. Of course, wind power is among the most valuable tools for towards achieving the green energy transition that will mitigate climate change, and of course for Greece it will augment energy autonomy and economic development. But without careful siting, wind farm development, especially at this scale and these areas, can have significant irreversible impacts on sensitive species, their habitats, and the relevant conservation targets of the sites of the protected areas designated for them. Thrace in particular is a typical example of problematic spatial planning, as some of the most important SPAs in the country designated for their importance for the conservation of large raptors, which are by definition the most sensitive species to wind farm development, was also selected as a wind farm priority area. We have thus, up to date, 265 installed and functioning wind turbines. 11 more are under installation, or I'm not sure, but now it might be even under testing regimes. And 74 more that have been granted environmental approval terms and are expected to be installed soon. We can therefore reason about a conflict between the unfolding industrial scale wind farm development and the conservation of priority species and the areas designated to this aim. As I said, there are 4 SPAs with sensitive trigger species. Among them, there are 3 species with extensive telemetry datasets that allowed us to look into our research questions. In particular, the last cinereus vulture population of southeastern Europe, estimated about 120 individuals. One of the largest griffon vulture population in continental Balkans at around 380 individuals. And arguably the most important continuous population of golden eagles nationally, 10 pairs from a number of, this population has been reduced from a number of nearly double in the past 15 years. So we looked at the collision mortality estimation. We used the published method of Vasilakis et al., who was part of our research team from his earlier relevant PhD research in the area. We calculated utilization distributions as fixed kernels on a plug-in bandwidth. For vultures, it was conducted for the breeding and non-breeding season as the methodology required. And for eagles, we adapted it to each year. We used the individual utilization distributions, averaged if we had one season of data from the same bird, and averaged them for the population by dividing with the number of birds in the end. We derived the flight height and speed above ridges from telemetry data, as well as the proportion of the population using its wind farm, again from telemetry data. This information was fed to the band collision risk model for turbines that are installed, under installation, and with published environmental approval terms, that is 350 turbines. And we extrapolated for future development scenario based on the number of planned turbines and conservative estimates of their use by the birds. So for the scenarios vulture, our data set spanned 2016 to 2022, was more than 2 million fixes, and was from 40 individuals. We used the avoidance rate of 98%, as required for species where this has not been calculated before, and this as it's accepted in the literature. And this resulted to 8.15 deaths per annum in the current capacity, in the 350 turbines, that's what we mean with current capacity here, corresponding to 6.8% of the population. In the extreme scenario where all planned turbines, more than 900 additional, are installed, this number turned to 36 deaths, with a conservative estimate of 10 to 8, realistic conservative estimate of 10 to 18% of planned turbines. This number turns to 13 to 16 deaths from collision per year, corresponding to 11 to 13% of the population. For the griffon vulture, our dataset was from 32 individuals, spanned the same period, again more than 2 million fixes. We used again the avoidance rate 98% that was corroborated for the area from an earlier study. And this resulted on 15 deaths per annum on the current capacities, corresponding to 3.9% of the population. With all planned turbines, this number turns to 27 deaths, corresponding to 7% of the population. And with 10 to 18% of planned turbines, 17 to 18 deaths, that is 4 to 5% of the population. For the golden eagles, we had telemetry data from 6 territorial individuals with more than 1 million fixes from the period 2000 to 2020, 2020 to 2022. For the 4 remaining territories, we used the predictions of the path ranging model that assigns a use value to a cell, an area cell, based on the distance from nest and the relief, the topography. We used the avoidance rate of 99% here. This resulted to 11.6 deaths per annum on the current capacity. And any scenario, of course, of increase leads to rapid population extinction. Even with the 99.9% avoidance rate, that is the highest used in the literature, it still amounted to about 1 bird per year, which is still significant for a declining population of this size. To investigate displacement, we compared the vultures' utilization distributions in different periods, dividing the latest to the earliest around turbines. For the scenarios vultures, these periods were 2016 to 2022 and 2009 to 2012, which was an earlier dataset used in the previous research. This produced an index more than one implies increase in use and less than one decrease in use. A similar approach was used for the griffon vultures, but we divided the available data in two periods between 2016 and 2018 and 2019 to 2021, but we detected no change. For the golden eagle, the time span of the dataset did not allow for this. So we looked at the behavior of tagged individuals around installed turbines in relation to their behavior around plant turbines in their vicinity with a use availability design. We isolated thus the 265 functioning, installed and functioning turbines and 444 plant within 5 kilometers around them. And we also took care to eliminate plant turbines that were within the 1 kilometer distance of the installed ones. We used as the use index the proportion of locations within 10 100-meter distance bands spanning, that is from 0 to 1 kilometer from each turbine, and the availability, the total area of each band. For the scenarios vulture, there was a pronounced reduction of ranging use near operational wind farms. We found that 81% of the 26 currently installed wind farms showed a reduced use, and in 38 to 58% of them, depending on the season that we looked, the effect of this reduction was very pronounced, exceeding 85%. Nearly all wind farms in this category had collision deterrent systems installed, 14 out of 15. For the rest of the wind farms, 23 to 30%, again depending on season, showed a reduction of 45 to 55%. For the golden eagle, there was again, we have an index that more than one implies avoidance, less than one preference, and values close to one and neutral behavior. There was a clear avoidance of operational turbines compared to plant turbines where there was preference. On the left, you can see the distribution of the locations around the turbines. The histograms of the right are a distribution of the preference index from 1,000 random samples of 10% of the data. So in operational turbines, there is a clear avoidance in the band of 0 to 100 meter category, and neutral behavior in the band of 100 to 200 meters. And the opposite happens in plant turbines, where it turns into a very strong preference for both bands. This is due to the preference of eagles to ridges, where updrafts are usually higher, more stronger, and also where the turbines are usually sited. For the golden eagle, I must say this displacement has another crucial dimension, as it's a territorial species with a continuous saturated population, assuming all the colonies, all the territories will be occupied. And this means that pairs that are displaced cannot compensate for this, essentially its habitat loss, by expanding the range in its neighboring territories. So as the conclusions, we can say that the SPA or Rhinoceros Quilada de Rio, which is still important for vulture transit and foraging flights, and it also maintains 4 pairs of golden eagles and 3 more vacant at the moment territories where habitats are still in good condition. And according to the official now conservation targets of the site should be reinstated. And it is likely as golden eagles tend to recolonize the same localities if the population is rebounding. So this SPA so far is relatively unaffected by wind farm development and should remain as such, as the previously exclusion zone proposals in the area, including the research mentioned earlier, require. And in general, it might be a good idea that spatial planning starts to take these proposals more seriously. It would largely mitigate the problem. The construction of more wind farms in Thrace, based on our analysis, can have significant irreversible impacts on the population of the three priority species, their habitats, and the sites designed for their conservation, as their estimated collision rates are very high and optimal habitat use is affected through displacement. As Lefteris stressed, a holistic standardized approach is required for the appropriate assessment and post-construction monitoring with subsequent dissemination of results that will enable the assessment of the impacts at the population level. And finally, the use of collision deterrent systems should be reevaluated as it might mitigate collision mortality, but at the same time it seems to be displacing birds from the habitats in protected areas. And at least in no case should be considered as the only necessary prerequisite for wind farm installation in sensitive localities. Okay, thank you.
Thank you very much, Lavredis. I think we should. Okay, here we are. Thank you very much for this presentation. And before we go to the next presentation, I have one question here on our Q&A. And the question is, all pre-studies and post-construction studies of wind farms are mainly focused on the threat of collisions.
Yes.
Based on your analysis, how important are at the end the displacement threat, and how this should be, or whether this should be included in the pre-studies, in the environmental evaluations, or even on national or EU legislation?
Okay, this cannot be answered. The impact of the displacement needs demographic data to be answered for a start in long-term monitoring. So for example, for the golden eagle, we don't have this data. On the other hand, we're talking about special protection areas, which are specifically designated for the conservation of these species. The legislation already protects their habitat, and displacement is an effective habitat loss. So, of course, they should be somehow incorporated in the impact assessments, and but this requires consideration as how this can be quantified on observational data, which usually the impact assessments use.
Yeah. Okay. Thank you very much for that. We don't have any questions for now, so we can move on to our next presentation, and we have with us Dr. Anastasios Bounas. He's an evolutionary ecologist with a special interest and expertise on how future environmental changes affects biocommunities, and we will be looking on some scenarios on the viability analysis for the black vulture, and an extinction risk assessment under the future scenarios of wind farm developments. Anastasios, the floor is yours.
Hi everyone, from me. I would like to thank the Society for the Protection of Biodiversity of Thrace for organizing this event. Now, on my part, I will try to provide a look in the past, present, and future of the population of Cinereus vulture in Dadia National Park, and the level of population, not just individuals, through the implementation of some population models that I will explain to you. So most of my colleagues have talked about the role, the possible effects of wind farms. You have heard about most of this stuff. So it would be more useful to tell you a couple of things about the basics of population ecology, so we are all in the same page. So 4 are the basic processes, let's say, that can affect, they can shape the size of the population. Some individuals are recruited in the population by emigration, or they leave it by immigration, but the most important role is played by births and deaths. So actually this difference between the rate of the individuals that are born and the rate that individuals die determines if the population increases or decreases. And that is the fundamental equation that we use in most of the ecological models, and we build upon that, let's say. So quantifying those parameters, births and deaths, survival, stuff like that, we can then examine how their change affects the population. And if they happen to change, if this change is really important. One basic approach used to assess how population will respond to increased mortality, let's say, to calculate those demographic parameters, calculate how they change, and then project the population through a population viability analysis. This is what the population viability analysis does. And that's what we did in this study. Long-lived species, such as the Cinereus vulture, are extremely sensitive to the additional adult mortality, as we will see. Currently, the population of the Cinereus vulture in Dadia consists of a colony numbering about 36 pairs and shows an increasing term in the long term, actually, but some signs of stability are shown in the last few years in the short term. It is known that such small, such spatially restricted populations can be subject to increased extinction risks, can be very, very vulnerable to increased mortality, to change, either from threats or from stochastic events. But in fact, despite the long conservation efforts in the past and the ongoing conservation efforts to mitigate the threats in this population, it's still affected by high mortality. Mainly that happens due to poisoning, illegal poison use, collision with already operational wind turbines, and electrocution with power lines. These are the 3 main causes of mortality in the national park. So on our part, to examine the state of the population, in what state the population is, we built an integrated population model, an IPM, for the species. You can see a graphical depiction of the model built here. I will not go into many details, but I'm available for everything you might need. Also in the reports in these studies that they will go online, everything is written there with much detail. So demographic parameters that we calculated are shown in blue circles. These are the survival for each age class, for juveniles, for immatures, for adults. It's the fecundity. So this is what we are interested to calculate. And these green rectangles are the data that we used in the model. So what are those data? We combined actually different sources of data that were collected by the guys in the Dadia National Park the last 3 decades, 30 years. Now, long-term monitoring of the black vulture, of the Cinereus vulture, and that include annual population counts, also breeding success data that has been done in the national park. And also we used data to actually to help calculate survival better of a long-term mark recapture program in Dadia. There has been, the guys have been putting wind tanks from, I think, 95 or around somewhere there. They've been putting wind tanks of birds. So we could know if a bird in each time, in its observation event, is being alive or dead. So using those data, first of all, what we did was to estimate those demographic parameters for the cinereous vulture population, and then use them to simulate the demographic change in the future and calculate the probability of extinction for the next 20 years. This is the first step is with no additional mortality. It's a baseline scenario. And the survival rates, what we found in the results was that survival rates have been a little bit low, especially for juveniles. The dynamic of the population, there are no actual big differences with literature. Productivity is slightly lower than for the Spanish population, for example. Then the dynamics of the population seem to be driven mainly by adult survival. That's consistent with a long-lived species like the cinereous vulture. So in years where adults experience low survival rates, then the population is decreasing. In years when adults have high survival, there is low mortality of survival birds, the population is increasing. It was the only demographic parameter that correlates with growth rate of the population. So between 1993 and 2021, the population of the cinereous vulture increased at a mean annual rate 4.3% per year. And when it was projected then in the future, in 20 years in the future, it showed a stability, actually with a very, very slow decline of 10% in 20 years. That means that we could be losing 3 pairs or something like that in 20 years until 2040. So after that, we moved on and used this model as a basis and examined the likely impacts of wind farm development in the region. And we calculated demography and extinction probability at 3 future scenarios of wind farm development. These scenarios were the ones previously presented by Lavrendis Sidiropoulos in his presentation. It included the establishment. Scenario A was the establishment of 85 wind turbines. 11 of them are currently installed, but they are not operating. And 74 have not yet been installed, but they have received the decision for the approval of environmental terms. So they are expected to be installed. So these 85 wind turbines lead to 1.94, almost 2 dead cinereous vultures per year. For scenarios B and C, it's the much worse scenario of 934 wind turbines that are designed to be installed in Thrace. And in these scenarios, the only thing that changes is the space use by the population. If the 25% of the population uses the space, we have a low use. Then we expect that 28 cinereous vultures will die every year. And if the majority of the population uses the area, 65 cinereous vultures will die per year. So in the first scenario, if those 85 future wind turbines with a positive decision for the approval of environmental terms will be established in the area, then the population extinction is estimated at around 16.4% after 20 years. Extinction probability you see here. And an overall 44% decrease in the breeding pairs is expected after 20 years by 2040. And that is compared to the baseline scenario that you see with a black line here. So we actually have a severe decline of the population. Now, as it's expected, I mean, most probably we wouldn't really need a model for that, but if 934 wind farms wind turbines are placed in the region, the population goes extinct within a few years. 90% probability of extinction is reached within 6 years from operation if the area is used by a small percent of the population. And then if most of the population uses the area around the wind farms, then within 4 years, extinction is like 98% probable. So summarizing, future increase in the wind farm density could lead to the destabilization of the population in all examined scenarios. The lowest impact scenario that we had in mind, the operation of 85 wind turbines, still greatly accelerates extinction risk within 20 years and severely decreases population size. That means that it's further limiting the population growth. We will have a rapidly declining population, and this population is really, really small now. It will be even smaller in 20 years and most prone to extinction. Of course, as expected, all these extreme scenarios of future establishment of wind turbines will lead to population extinction. It cannot be avoided. Our results actually give a quantitative warning, let's say, on how this additional mortality can impact the population viability of long-lived species, such as vultures. They further highlight the need for examining those impacts, wind farms, on the population level, rather than focusing on just individuals or there's not many dead individuals, but still the population level picture is the one that can give some information about the long-term impacts of wind farms. One of the main priority tasks for successful conservation of the Cinereous vulture is to reduce non-natural mortality. That is shown by our results for sure. So this has to be done by reducing all those severe threats that operate in the area, illegal poisoning, and the operation of already installed wind farms. This somehow needs to be tackled. It could be that this wind turbine-related mortality can be actually lowered by removing some wind turbines that have been found to be associated with high collision risks. And of course, future planning of the establishment of the wind farms in the area should consider taking in mind the species, the endangered species in the area, and be done outside of the areas that are critical for such species. Thank you very much. That's it for me.
Thank you very much, Anastasis, for an excellent and very interesting presentation. Let's hope that the doom scenarios don't materialize and logic prevails, and we have a reduction in the intense investments planned for the future. Now, I have one question for you, but before moving on to that question, as we are approaching the end of our meeting today, I would encourage anyone from the audience who wants to write questions in the Q&A overall, and to whomever speaker they want to address. We still have some time. We are exactly on schedule, so we have the time to take more questions if you want, bar the questions that have to do with the land cover impacts of roads and wind farms, because Dr. Tsistrakis and Dr. Damianidis had a preoccupation and had to leave a bit earlier. Now, going back to you, Anastasis, I have a question, which is, it says, given the business as usual, even under the business as usual scenario, we see that after 2022, we still have a small reduction in the population of the black vulture. And where does this, could that be that the population have reached a certain limit for the space available? Or anyway, what are your estimations of that?
Yeah, this does not seem very, very probable, let's say, that the population has reached its limit. It's more that the cumulative effects of every threat are starting to show in the population after some years, especially in long-lived raptors, that they take 5 or 6 years to reproduce for the first time. So this increased mortality is shown with some time delay. What I mean is that still in the last years, we already see a stability in the population trend. It's not something that will happen. We still see that something is reducing, something reduces this population's ability to grow. That probably, for me, it is all those threats. It's a mix of all those threats operating right now as the already installed wind turbines and the illegal poison use, for sure. Threats that operate and kill breeders. Of course, another thing that shows that this is not the case, that the population has reached, let's say, its current capacity, is that we don't show any immigration out of the area. We would have some colonies outside from Badia National Park in Bulgaria. There is a very good habitat in Bulgaria, for example, but we don't see any birds breeding there. So it's not that this population is limited that way.
Okay, thanks a lot. And another question popped up now. Does the size of the 84 wind turbines under scenario A, the size of the rotor blades matters, makes a difference? And have the scenarios taken into account the automated system for the DT-BIRD for avoidance of collision?
Probably Lavrendis would be the most capable person of answering, because the scenarios are actually from this study. So I'm not sure.
So maybe Lavrendis, you want to pick this up?
Yes, the technical characteristics of these turbines. Are you talking about the 74?
The 84, yes.
Okay. The tech are known for these turbines, and given that we already have collision deterrent systems installed in populations, the mortality given to Tassos under the current scenario largely incorporates this.
Good. Thank you. And another question that was directed to Anastasis, but would probably be answered by some of the other speakers as well, is: do we have the percentages of the main causes of mortality that you refer to, poisoning, wind farms, electricity? So, mortality distributed.
That could be done. Actually, I don't have it in front of me. It could be done. We could see how many birds have died from those threats. But the trap here that we shouldn't fall in is that from every threat, we do not find all individuals. So if I say to you that from poisoning, we lost two Cineros vultures per year, this is not the real impact of the threat, because the probability of finding those dead birds is really low. So we could give an estimate from the percentage of each threat, but still we have to take into account the probability of finding dead birds from each threat. If, for example, electric pylons are monitored daily, then yeah, your census data may match the reality. You find all the dead birds in the pylon, but that doesn't happen. But it is doable. I mean, it could be done.
Okay, thanks a lot. And I think that was the last question. Anastasis, again, thank you very much for
thank you too. Many thanks.
And I have another question from a while before. It was submitted a bit later, and it refers to you, Lefteris, Mr. Kakalis, and it follows up on the discussion we had on the DT-BIRD system. And the question is whether all wind turbines are obliged to have this system, if it is obligatory, that is, and if you know since when this has become obligatory for new investments.
There is obligatory for many wind farms, but till now, few of them they put the systems. We just wait for the rest to put the systems, but As the other colleagues mentioned, the automated systems may help or minimize the problem, but as Tassos said, the trend of the population it will be the same. They incorporate in their models this fact. So, if I answer, that was, I don't know if I gave an answer to the question.
Yeah, I think you have, Thrace. What I understand is that they are obligatory, but this is not always.
It is obligatory for many wind farms, but we are still waiting for the companies to put these systems on.
But I understand from most of
the other thing is that the trend of the obligation to put these systems is raising the recent periods from 2016 till today. There is a growth on this environmental condition and many wind farms are obligated to put them. But this is not the solution of the collision of vultures and raptors.
Yeah.
We should consider this.
I think that experience from many environmental fronts show that all these end-of-the-pipe solutions, are just the last resort. There are many things we need to do before, and I think what we've heard today is that there is no substitute for the proper siting, proper pre-construction evaluation of possible impacts and proper design and siting of the investments. I think we wrap it up. I don't see any other question on the Q&A session. I want to thank all the speakers for these great presentations and the good discussions, and for keeping up with the time limits and making it possible to end in time. All the presentation will be uploaded in the next days on the website of the Society for the Protection of Biodiversity of Thrace. Once this is done, an email will be sent to all registered participants with a link, so you can go download and study these reports yourself. On our side, we have already started to distill the main conclusions and trying to disseminate them and provide guidance to authorities and educate the decisions made by authorities, but also from investment. So we are starting out on this work. Closing, a big thank you to, of course, the speakers, as I said, and the whole team that you have not seen today. Doras Kartsi, Ella Kret, Eleftheris Kapsalis, is the team of the society that has worked from day one to make all these studies possible, and who have made also this event yesterday and today and all these presentations possible. And a big thank you to the always, the heroes who never appear on this kind of events. Xenofondas Hadjidimitriou, Thodoris Yutos from the Sustain events, who have taken care of all the technical issues and made our discussions possible. Again, many thanks for your participation, and have a great afternoon. Bye-bye.